Hi Apes. Today we're going to be taking a look at Unit 2, Part 2, which is going to focus primarily on ecological succession. So before we begin with succession, we have to understand what might lead to succession, because succession is an ecosystem's response to a disturbance. So there are different types of disruptions that might affect an ecosystem. Now they can be natural or human caused. So natural types of ecosystem disruptions, think natural disasters, things like storms, hurricanes, tornadoes, earthquakes. For human caused, it can be small scale or large scale. They can be deforestation or forest fire, but they can also be things like climate change, so they can be on a large scale. Now, they can also be what we refer to time-wise as random, periodic, or episodic. So things that are on the larger scale are episodic, so things like sea level rise that might be caused by climate change or even natural changes in sea level rise like we've seen in geologic history. Plate tectonics, the movement of our continents, that is an episodic experience. Things like storms, earthquakes, those are random, and our seasonal changes, those would be periodic, so those would be expected to happen. Now, sometimes you might have the major habitat changes when you have plate tectonics, when you have sea level rises, that drastically changes our habitat. But sometimes they can be small and that can have an impact as well. Now, sometimes the animals, they might respond by something as simple as migration. So that would be respond to a seasonal change. One thing to remember about migration, though, is it does imply a back and forth. So this wouldn't apply to things like climate change, because with climate change, you're not going back and forth. You are just maybe moving to a more appropriate habitat. So just be careful with that term migration, making sure that you are implying a back and forth movement. So ecological succession is a ecosystem's response to change, and we do have two main categories of that: primary succession and secondary succession. Now, it's not that one happens first or second. The key differences here are what you start with. So for primary succession, the key thing is you have no evidence of a previous habitat. You have no soil, you have no seed, you have no nutrients. You start with bare rock. Now, there are two primary things that lead to our primary succession, and that's a volcanic eruption and the retreat of a glacier. So when a glacier retreats, it kind of pulls back from the water boundary and it scrapes the ground below it. So this is ground that has been covered by miles of ice for millions of years, so nothing but rock left behind. So the key thing there is you start with bare rock, no previous remnants of an ecosystem. With secondary succession, you do have something to start with. You have soil, you have nutrients, you might have some seeds left behind. So secondary succession, you do have remnants of the old ecosystem. One of the most classic examples of secondary succession causes is a forest fire. And now that actually can be a positive change, that some ecosystems and some biomes are actually driven by fire and need fire to occur. So succession is a typical, predictable pattern of change in the plant communities that you have. And a lot of it has to do with the availability of light and the availability of nutrients as to what types of plants will be growing there. So this first example that I have here is primary succession. The key thing here is that you start with nothing. You start with bare rock. So the first step of primary succession is actually the formation of soil. You have to weather that rock away a little bit. You have to have some pioneer species. Pioneer species are the ones that first colonize an area. In primary succession, they tend to be lichens and moss. So things that don't need soil, these can go directly on the rock and actually help to facilitate that weathering process of the rock. So as those lichens and mosses help to weather that rock away or physically and chemically break that rock down, they will also add organic material because they'll start to decompose, and so they'll start to add some organic material on top of that weathered rock, and that's actually the first stage of forming our soils. So over time, and here I'm talking about thousands of years for this to occur, to actually start to build up soil, you might be able to have some fast-growing shrubs and grasses that grow here. So these guys will need a lot of light. They won't have a lot of nutrients, so they'll be very generalist type species. And they're very fast growing. And now what happens is they will die, decompose, and add their organic material and really help to contribute building up that soil layer for the next group of trees that are more bushes and shrubs. These again need a lot of light because there's nothing up top shading them, so they can love light and they can grow well in light. They will die, decompose, add to the soils, and really start to set the stage for some larger trees. So the first types of trees you tend to see in an early forest are pine trees. Pine trees tend to be very fast growing and they like a lot of light. So what happens here is now we're going to really start to see a change and a shift in our ecosystem, and that as these pine trees grow, they're going to create shade on the bushes that grew prior to them. And now remember that the bushes and the shrubs, they needed a lot of light. So as the pine trees grow, they shade out the bushes and shrubs so that they die, and so now you have a dominant pine tree forest. Now the pine trees also create shade that allows hardwoods to germinate. So our oak and our maple, they will start to germinate, protected by the pine trees. And as they grow, they'll start to shade out the pine trees. Now remember, the pines wanted some light. And so as the hardwoods will grow and mature, they will shade out the pine trees. So when you tend to see a hardwood forest, that tends to be what we call a climax community, that it's not going to change much more unless there's some type of a disturbance that comes through. So it's this very predictable change in a plant community based on light conditions and nutrient conditions and the surrounding plant communities that are there prior to them. So you start with bare rock, then you have your pioneer species of lichens and moss, your fast-growing shrubs and herbs, then your larger bushes. And that sets the stage for pine trees because you've really developed that soil. The pine trees need that light. They shade everything else out before them. They allow or help or facilitate the growth of hardwood trees. And then the hardwood trees pay them back by shading out the pine trees, and then the pine trees will die out. So you'll see this typical pattern of succession or change in this ecosystem. So here, one key thing just to point out one more time is remember you started with bare rock because this was primary succession. So the difference then between primary and secondary succession is really just what you start with. It's the disturbance that led to it. So with secondary succession, remember we do have remnants of the system behind. If there was a forest fire that came through here, you would have soil, you would have nutrients, you would have seeds. So you start with something. So secondary succession tends to be much faster because you don't have to build that soil up. So with secondary succession, you start with maybe some weeds. Those are going to be your pioneer species, your generalist species. Those grow to the fast-growing shrubs and grasses. Those will lead to the pine trees that like the lot of light. They'll shade everything out before them. They'll create a good habitat for our hardwood trees to germinate, and our hardwoods will germinate, and they will pay them back by shading out our pine trees. So again, you tend to have your climax community, at least here on our East Coast, as our slow-growing hardwood trees. So if you see a hardwood forest, it's a pretty fair bet that that's a relatively old forest and a very mature forest. If it's primarily a pine forest, it tends to be very young, and if it's an open field, you can pretty much have a good guess that a disturbance happened in the relatively recent past. So again, succession is just that predictable pattern of how an ecosystem changes.